First thing I want to bring up is the fact to just give you guys kind of an idea of what we're like for the rest of the try, I guess. Um, so we're basically going to be finishing chapter 8 up until January 21st. January 21st is the last day of the trimester. And so in terms of pacing, it's kind of about a section a day. So it shouldn't feel ridiculous. And the good part is that it's going, we have enough extra time where if one section, we're having trouble with, we can certainly take even like an extra day if needed. So that's this chapter in a nutshell. I should have written this down, but I forgot. If you haven't, go into today's folder and do the attendance question. So it's super easy to forget that because we haven't been doing it for the last, 3 weeks or so. Make sure you go in there and do the attendance question. Because I know I got a couple of people messaged me later in the day that they couldn't do the attendance. So try to get the attendance done right away. Because then I put attendance in right after the class hour. Okay. So today's is on prime factorization. Who should we go with? Look at this. This is awesome. Everybody's here. Let's go with Sam. Sam, let's go with you. Do you remember what a prime number is? Because that's probably key for us to know prime factorization. Like, I'm not even looking for a good definition. Do you remember what a prime number is, Sam? Okay, let's go with Maggie. Maggie, do you remember what a prime number is? Uh-oh. Hey, can you guys hear me? Okay. I'll just ask anybody rather than just calling on people here. Does anybody remember what a prime number is? Yeah, well, that's like a real definition. That's a good one. Most people think of it as just the fact that no numbers multiply into it, right? Oh, I see. I forgot to open up the chat window. I've got it now, Maggie. Thank you. That's all right. No problem if your audio is not working. So prime number is no numbers multiply into it, except for 1. 1 doesn't really count. An example would be like 11. No numbers multiply into 11. So then that would be called a prime number. So we're going to do prime factorization, which kind of leads up to what we're actually working on today. And so prime factorization, let's pick the number 60. This is going to be called a factor tree. I'm sure you're going to remember doing these as soon as we... Decia, give me any two numbers that multiply to 60. Ten and 6, that works. That was going to be my thought as well. Okay, so I'm going to branch off 60 and do 10 and 6. Now, a factor tree works no matter what numbers you pick. So like if you decided to put 20 and 3 or 15 and 4, it still works. Asher, how about you? What about, does 10 have any numbers that multiply into it? Five and 2, okay. 5 and 2. Abdishakur, how about 6? And maybe his isn't working very good. Ava, how about you? Does 6 have any numbers that multiply into it? Yep, Jackson, that's true. For a lot of you guys, is the Zoom working fine? Like, that's really all I'm concerned with. Like, I'm not sure why a lot of you aren't answering. What? Okay. Okay, so, because I know some people had, like, for whatever reason, a lot of the Chromebooks weren't connecting to Google Meet before. So that's why I'm wondering, like, Abdishakur, I know you had a lot of troubles with Google Meet. Is Zoom working for you? Okay, well, we'll kind of keep going from here. So right now, I'm going to keep breaking down every single number until they're all prime. So like say when I get to 5, no numbers multiply into 5 because it's prime. 2, no numbers multiply into 2 because it's prime. No numbers multiply into 3, no numbers multiply into 2. Oh, okay, that's fine, Abdishakur. I just wanted to make sure everything was working. Yeah, the buttons are different on all of these. I know that's super annoying. So once you have a number broken down as far as possible, this is known as its factor tree. And so usually you would write the numbers in order from smallest to biggest. So 2 times 2 times 3 times 5 is what makes up 60. Let's do another one together here, quick. Let's do 40. Ayla, how about you? Do you think you could just kind of, oh, yep, perfect. I was going to say, I don't know if it would be easier. Does 10 break down any farther? Okay. How about 4? Perfect. Do any of these numbers go down any farther? No. So, okay, perfect, we're done. So this would be the prime factorization of 40. So you'd have 2 times 2 times 2 times 5. All right. Now, we use this when we want to figure out what numbers something is made up of. Okay? Now, this is going to be a separate topic. And I can pick the same two numbers. I'll just do 1640 again. So this isn't going to be the prime factors. This is going to be, they call it a factor ladder. And it's kind of similar, where you're trying to figure out what numbers it can be made up out of. But you display them differently. So like 60. 60 is made up of 1 times 60. And then you try 2. 2 times 30. And then you try 3. 3 times 20. And then you try 4. 60 divided by 4 is 15. Then you try 5. 60 divided by 5 is 12. Then you try 6. This is actually kind of weird. I don't think I've ever run into a number where all the numbers work in a row. 6 times 10. And then you get to 7. 7 doesn't go into 60. Then you try 8. 8 doesn't go into 60. Then you try 9. 9 doesn't go into 60. And then as soon as I get to 10, I'm done. Because all of the numbers bigger than 10 are already written off here. So this would be like factored ladder, I guess is the best term for it. So these are all the possible factors of 60. 1 and 60, 2 and 30, 3 and 20, 4 and 15. Okay? So these are the factored ladders. And you don't have to write down all of these. You can just kind of do it in your head if you want. Why don't you guys take a minute to see if you can write down all the possible factors of 40 using this factored ladder method. And I'll show you next the whole point of this. Christian, do you think you could help me out with the factor pairs for 40? Yeah. There's not too many of them. I don't remember. 1 and 40. Good. Good. 3 wasn't there, so I skip it, right? 4, 10. What, is there another one? Okay. 5 ends up going into it as well. So 5 and... Oh, gotcha. No, 5 goes into it. But then you're correct. 6 doesn't. 7 doesn't. And so then we're actually done because 8 is the next number up. Okay. I don't know. I don't think we need to do a ton more examples of these because I think you guys remember this from before. So then we'll get to what we're actually doing today. And today is actually about the greatest common factor. So it's sometimes called the GCF, but it stands for greatest common factor. Basically, there's definitely going to be times when we want to know what's the biggest thing that goes into multiple items. Okay. So what is the greatest common factor of 24 and 60? And there is 2 different ways of doing this. And so this is going to be the whole reason why I reminded us of factor trees and factor ladders, factor pairs, whatever you want to phrase it as. So they're completely different ways of finding the answer. But our goal is, what is the biggest number that goes into 24 and goes into 60 at the same time? So the first method I'll show you is the trees. And you absolutely pick whichever one you like best. So method number 1, I'm going to do a factor tree on 24 and a factor tree on 60. 24. Let's go with 4 and 6. 6. I think we did 60 up above. Yeah, we did. 6 and 10. Okay. So the prime factorization of both of them, you want to write and circle any of the numbers they have in common. But they have to be pairs, right? So they both have a 2. They both have another 2. And then they both have, we need to find another color. They both have a 3. So as soon as you find out the pairs that they have in common, their greatest common factor is going to be 2 times 2 times 3. The ones that they had in common. So 4 times 3, or 12. So this is one method to find what's the biggest thing that goes into both. Method number 2 is like the ladder. So I'm going to make a separate one for 24 and a separate one for 60. 24 is made up of 1 and 24, 2 and 12, 3 and 8, 4 and 6, and that's it. 60, 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10. And then you are specifically going to find the biggest number that they both have in common. So they both have a 1 in common, a 2 in common, a 3 in common, a 4 in common, a 6 in common, and a 12 in common. So I'm just paying attention to the numbers they have in common. The biggest one is 12. So the greatest common factor would be 12, because that's the biggest one they share. Now, I'm going to assume one of these two methods feels easier for you. I will tell you the most popular one is the one on the left. No, let me rephrase that. In Algebra 1, the most popular one is the one on the right. As you get higher up in math, the one on the left becomes more popular. And that's, I can show you why in a little bit. But these are the two methods. Does anybody want me to kind of explain anything I did up there? Or, I can, anything. How did this feel? If you guys can, in the chat window, I know you've probably done this in classes before, a fist to 5. A 0 means you don't get this at all. A 5 means you feel like you fully understand it. Could you guys type in a number from 0 to 5 as to how you feel like this is going? Okay, that definitely tells me I will move on faster. I'm going to take it from you guys. I shouldn't even give you a problem to try, because it sounds like you guys already flat out know it. Okay, good. Then I'm going to move on to the harder versions. But honestly, that's really good to hear. Your wife was down? That's an unfortunate typo there, Sam. Okay, the GCF of 3x cubed and 6x squared. So obviously these are slightly different because they've got letters in them. Okay. So we can somewhat approach them similar. What I'm going to recommend to you guys is approaching them as the factored trees. So the number 3 is already prime, so it can't be broken down, but 6 can be broken down into 2 and 3. So you're going to treat the numbers and letters as separate. But I'm going to write them as broken down as I can. So 3x cubed could be written as 3 times x, like that. 6x squared, 6 can be broken down into 2 and 3. X squared is 2x's. So when they have variables, often it works better to kind of picture everything separately like this. And then you go through and circle any common factors. So 3's are in common. We have an x in common. And we have another x in common. And so I find anything that they have in common. And so my GCF is made up of all the common information. So it would be 3, an x, and an x. So 3x squared would be what they both have going into them, the common factors. Maybe I feel like I should probably give you guys one of these to try. But before I do that, does anybody, have any questions on this with variables? Okay. I mean, honestly, it sounds like you guys remember a lot of this from before, so that's pretty awesome if you do. So why don't I give you guys one to try? Why don't you guys find the greatest common factor between those two? Taylor. Oh, I don't know if I cut you off way too early or not. Do you think you figured out the answer? Close. I'm gonna guess that you're kind of confused on what to do with the letters, because that's where you sound the most unsure. Okay, here's what I'll do. Oh, give me back my markers. There we go. Here's what I'll do. We'll figure it out together. Okay, so I'm going to do the numbers first. 18, 2 and 9. 2 can't be broken down, but 9 can. 9 can be 3 and 3. So 18 is made up of 2, 3, 3. X cubed is made up of x, x, x. Y squared is made up of y, y. Okay, and then I go to 24. 4 and 6. 2 and 2, 2 and 3. So 24 is 2, 2, 2, 3. And then we've got a single x, and we've got 3 y's. Now we basically just want to find all of the pairs. So I see that they both have a single 2 in common. They both have a single 3 in common. And then I get to the letters. They only have one x in common because this one only has one x. And then we get to the y's. They have 2 of them in common because this one has 2 and that was 3. And so everything I just circled would be the common answers. So the 2 and the 3 that they have in common make the 6, so that was perfect. A single x was circled, and then y times y. So then this would be the greatest common factor. How was that, Taylor? Did you kind of figure out where you went wrong a little bit? Okay. That's kind of what it seemed like, yeah. Okay, how about anybody else? Is anybody else maybe making little mistakes that they're not sure why they're getting part of it wrong? I would say this is one of the more difficult questions you'll get, actually, because I gave you multiple variables and numbers and everything. So if you got this one right, you're basically going to get all of them right. Okay. Do you guys want me to put up another example for you to try? Or do you guys feel pretty good about this? You're awfully silent today. How about, it seemed like you guys didn't mind typing the numbers into the chat. Do you want this problem that we just did, how do you feel about it from I don't get it to I got it correct? All right. Decia, 3/4. That's an oddly specific answer. And I'm just kidding. I knew what you meant. Okay. Well, I'm going to guess that after doing the homework, the homework is going to start with the easier questions, like what's up here, and then kind of work our way into this is the most difficult. It sounds like a lot of you are doing pretty decent on today's, and that's a good sign. So I mean, like, even if you said 3 on this, because you feel a bit iffy, this is the hardest that you'll get. So that's a good sign. Why don't I stop here then? Because I want to make sure to give you guys some time to work on the homework. And do know that the homework, it looks like there's a lot because there's 3 separate things, but they're all small ones individually. So you'll find that the homework goes very fast. So why don't I stop here so you guys have a half hour to work on homework. I'll stay on here for a little bit if anybody wants me to help them. Other than that, you guys are welcome to send me messages throughout the day. And, as a reminder, I'm on every day from 1:15 to 2:30. If you have questions for the open help sessions, you can just kind of drop in. I won't lie. I've heard from most students that Zoom and Google Meet are about the same for them. Zoom works a million times better on my computer than Google Meet does. And I'm assuming it's because I could download the app for Zoom rather than do it in the browser. but so far I think I'll probably stick with this because it works a lot better on my end. Like you guys are all coming through clear and everything shares easy. So either way, I guess we're done for today. Appreciate you guys coming here. Definitely do some makeup work if you guys are falling behind. Catch up. We only have a couple weeks left of the trimester.